Hi, so in this video I'm going to show you the solutions to practice set number 18. Here's the solutions to the first four. There's video links for those if you want to see exactly how those are done by a different person. You can. Those are the solutions I got. So let's start with number 5. We're trying to find h prime of 7 over 4. And we'll notice that h and g are the inverses of each other. So we want to find h prime of x, which means h prime of x, we're going to use our little formula, is going to be 1 over g prime of h of x. Right? It's 1 over the derivative of g evaluated at h of x. Because we want to know h prime of 7/4, let's go ahead and just plug in 7/4 and let's talk about what that means. 1 over g prime of h of 7/4. Right? So in order to do this, you have to notice like several things. One, I need a g prime, which means at some point I'm going to have to take the derivative of this. And two, I need to know what h of 7/4 is. And all we really need to do in this is, in order to know this, is that if they're inverses, if two functions are inverses, then their x and y coordinate are switched. And I'm given some information up here that g of 2 is 7/4, which means h of 7/4 is 2, right? The x and y coordinates shift. So that tells me what this h of 7/4 is, right? So really, h prime of 7/4 is going to be 1 over g prime of 2, right? Because h of 7/4 is 2. So now all I'm left with is 1 over g prime of 2. So basically, I need to take the derivative of g, plug in 2, and then write 1 over that, right? So let's start with the derivative of g. G prime is going to equal 3/8 x squared plus 1/2, just some chain rule stuff, right? And then I need to plug in 2, so it's going to be g prime of 2, 3/8 times 2 squared plus 1/2. 2 squared is 4, so this is going to give me 4 times 3 is 12 over 8 plus 1/2. 12 over 8 is going to simplify. You can divide both top and bottom by 3. I'm going to get 3 over 4 plus 2 over 4. I don't know what that is. It's going to give me 5 over 4, right? 1/2 is 2 over 4, so that's 5 over 4. So now I know this is g prime of 2. I know what that is. It's 5 over 4. So h prime of 7 over 4 is going to be 1 over 5 over 4, which dividing by a reciprocal is the same as dividing by a fraction is the same as multiplying by the reciprocal. So I should get 5/4 on that. Okay, so for number 6, same idea, except you're given a table here. F and g are inverse functions. We're given some values of f and g and f prime. We want to find g prime of 2, right? Down here it says find g prime of 2. So we're going to use that same formula, right? G prime of x is going to be 1 over f prime of g of x. And then I need to plug in 2. G prime of 2 is going to be 1 over f prime of g of 2. Right? Now I just have to figure out what these things are, right? G of 2 is going on this chart. I look at G and I look at 2, right? Which is going to be 9. So that's 9. So really, I'm left with this, right? We're just simplifying little by little. G of 2 was 9. Therefore, I can replace G of 2 with 9. And now I'm left with 1 over f prime of 9. Well, if I plug in 9 to f prime, I get 1/12. So really, this is g prime of 2 is 1 over 1/12, which is multiplied by the reciprocal, 12. All right, so that's the answer to that one. I guess we can write it over here, right? 12. There's our answer. For number 7, it says a particle is moving along the x-axis, so that its position, right? We're given the position function. That's important. At any time greater than 0 is x of t, right? So x of t is our position. Find the velocity at the indicated value of t. Do without a calculator, then check with a calculator, right? So here, I need to find the position. Sorry, I need to find the velocity. I'm given the position. So basically, I'm just trying to find x prime of t, which will give me the velocity, right? The derivative of the position is the velocity. So I'm trying to take the derivative of this sine inverse function, right? My suggestion, I just brought this up, is to go find a little chart and find arcsine on there, right? So arcsine, you can see it on the left of my screen here. It's u prime, or the square root of 1 minus u squared. here is my u, right? It's the thing that's inside the sine inverse function. So I'm just going to go ahead and plug this into the formula. Negative u prime, so it's going to be negative, the derivative of square root of t over 4 is going to be 1 over 8 square root of t. You can check that if you want. Just, you know, it's like 1/4 times square root of t. Square root of t is 1 over 2 square root of t. You know, you can take all the steps if you need to. And on the bottom here we have the square root of 1 minus u squared, where remember u was square root of t over 4. All right? And let's go ahead and simplify this a little bit, right? V of t, the velocity function, is going to be 1 over negative 8 square root of t divided by the square root of square root of t squared is t over 4 squared is 16. All right, so for now we're going to leave it like that. We want to know velocity when t is 4, so we're going to find v of 4, which just means I plug in 4 everywhere I see a t, so it's 1 over negative 8 square root of 4 divided by square root of 1 minus 4 over 16. Do some simplification. This is going to be 1 over negative 16 over 4 divided by 16 is 1/4. 1 minus 1/4 is 3/4. And then this is like 3/4 over 1, which, let's go down here, a little more space down here. This is a 16. It's going to be 1 over negative 16 times square root of 3/4. And I think that's as simple as it's going to get. All right, so let's go to the next one. B is x of t is tan inverse of t squared. We want to know when t equals 1. Remember, you can't plug in first, right? If I just try to plug in first and then take the derivative, I'll always get 0. So I actually need to take the derivative and then plug in. Arc tan we can find over here is u prime over 1 plus u squared. So, right, we're taking the derivative of the position function. We're getting this velocity function. It's going to be 1 over, sorry, u prime over, u prime in this case, sorry, one second. Sorry, the whole thing disappeared on me there for a second. So arc tan is u prime over 1 plus u squared. So here's our u, right? It's this t squared. So arc tan is going to be u prime, which is going to be 2t all over 1 plus u squared, right? Which this is going to simplify to, my velocity function is 2t over 1 plus t to the 4th. We want to know the velocity at 1, so it's going to be 2 times 1 over 1 plus 1 to the 4th power, which is 2 over 2, which is 1. So my velocity at time equals 1 is 1. All right, so let's keep going. Number 8 says find an equation for the tangent line to the graph of y equals tangent x at the point pi over 4, 1. So I need an equation of a tangent line. At this point, we should know that this means y minus y1 equals m x minus x1, where m is the derivative at x1 and y is simply the function value, the original function value at x1, right? We're given both of those right here, right? We're given x1 and we're given f of x1, the y value. So all I need to do is find the slope. So my function is y equals tangent x. My slope is going to be the derivative, which hopefully I have this memorized by now. Derivative of tangent is secant squared x. And then I want to know the slope at pi over 4, which means I'm finding secant of pi over 4 squared. Okay, so I need to find secant of pi over 4 without a calculator, right? And this is something that we should be able to do. We should know that secant is 1 over cosine. Right, we have secant squared, so it's going to be 1 over cosine squared of pi over 4. Unit circle, pi over 4 is here. Those coordinates are root 2 over 2, both of them. Turns out the cosine is the pi over 2, or square root of 2 over 2. So it's going to be y prime of pi over 4 is going to be 1 over the square root of 2 over 2 squared, right, because it's cosine squared, which is going to give us 1 over 2 over 4, which simplifies to 2, right? So the slope is 2, and therefore my equation, I have all the other information, right? My equation will be y minus 1 equals that 2 I found, x minus pi over 4. That's the equation of my tangent line. All right, find the equation for the tangent line to the graph of tan inverse. In this case, we need to take the derivative of the inverse tan, which is u prime. The derivative x is 1 over 1 plus u squared. U is x in this case, so it's going to be 1 over x squared. We want to know the slope at 1, right? So we're going to get 1 over 1 plus 1 squared, which is going to give us 1 over 2. Right? The slope there is 1/2. So now we have all the other information. Y minus pi over 4 equals 1/2 x minus 1. Right? And so notice something about the slopes of inverse functions, and also notice how those x and y coordinates are switched for the inverse functions. All right, let's keep going. Number 9, we're given f of x here. We want to find f of 1 and f prime of 1. Okay, so let's go and start with f of 1. F of 1 is simply just plug in 1, see what you get. And if I plug in 1, I'm going to have 1 plus 2 minus 1, which is 2. Right, and then f prime of 1 is, well, first I need to find f prime of x, which will be 3x squared plus 2. F prime of 1 will be 3 plus 2, which is 5. Right, so there's 2. How can you find f inverse of 4? F inverse of 4, right? If f inverse of 4 equals b, that means that f of b will equal 4, right? I plug something into my original function and I get 4. What that's saying is the 4 is the f of x piece, and I'm trying to find what x value do I need to plug in here to get that, right? And you can just solve this, right? I can add 1 to both sides. I get 5 equals x cubed plus 2x. Actually, sorry, that's not the way to solve this. I need to move the 4 over to get 0 equals x cubed plus 2x minus 5. And then factor, and I'm going to get, it's not going to be factorable. Sorry, this is, I didn't see it here, it's at negative 4, right? So it's f inverse of negative 4 equals b, and f of b equals negative 4, which makes this a add 4 to both sides, which means I get positive 3 here, which makes this still not factorable. Right, because it's not quadratic, I'm not going to be able to factor this, but I can try to think of some numbers that I could plug in here that work, right? Can I plug in any positive number I get here is going to keep adding up and be more positive. So just to think, like, what could I plug into this to give me 0? It's got to be negative. Let's just try the first negative one. Negative, if I plug in negative 1, I get negative 1 plus negative 2 plus 3, which will give me 0, right? So the value that makes this work is negative 1. There's no real easy way to like solve this because it's a cubic, but we can just guess and check with some numbers, right? If I plug in negative 1 here, I will get 0. So x equals negative 1 is the value here, which means that f inverse of negative 4 gives me negative 1. The reason I'm interested in that is because this is the number I would plug into the formula down here for part C, because f inverse prime of negative 4 is going to give me 1 over f prime of f inverse of negative 4, right? I'm using that formula again, and now I know what that f inverse is of negative 4, right? I know f inverse of negative 4 is negative 1, right? So I can replace that with just 1, right? So it's going to be 1 over f prime of -1. And then I just need to find, well, what is f prime of -1? Let's find f prime. We already found f prime, right? F prime was up here. It was 3x squared plus 2. F prime of -1, down here, f prime of -1 is going to be the same thing, really. -1 squared is 1, times 3 is 3, plus 2 is still 5. So here we're going to get 1 over 5. And so the derivative of the inverse evaluated at -4 is 1/5. Let's try f inverse prime of 2, right? F inverse prime of 2. I don't need to rewrite this formula, or I mean I'm going to, but f inverse prime of 2 is going to be 1 over f prime of f inverse of 2. So I need to find what is f prime of f inverse of 2. So we need to find f inverse of 2, which, remember, that's if the 2 is the input in the inverse function, then it's the output in the original function. So basically I'm trying to figure out at what x value do I get a 2 as an output. And kind of neat up here is we already did this. We already found that f of 1 gave me an output of 2 in part A. So that is that f inverse of 2 will give me 1, because f of 1 equals 2. So this equals 1 over f prime of 1. So I need to plug 1 into my derivative, which we already did up there, and we end up getting 1/5 again. Because f prime of 1, we found up here, f prime of 1 was 5. Okay, so we're on number 10 now. We're given f of x equals x cubed minus 4 over x. Part A asks us to find f of 4 and f prime of 4. Let's just start with f of 4. Means I plug in 4 to my function, which is going to equal 4 to the third power is 4 times 4, which is 16. And 16 times 4 is 64 minus 1, which is going to give me 63, right? So this is f of 4 equals 63. The next piece is f prime of 4. Let's start with f prime. F prime of x equals 3x squared minus the derivative of 4 over x is the same as 4x to the -1. Bring in a -1, it's going to be, it was -4, now it's going to be positive 4x to the -2, which is going to be 4 over x squared. Right? So that's the derivative. We want the derivative evaluated at 4. Which means we're going to plug in 4. So it's going to be 3 times 4 squared minus 4 over 4 squared, which is going to equal 4 squared is 16. 16 times 3 is 48, minus 4 over 4 squared is 1 over 16, which is 1 over 4. So I have 48 minus 1 over 4, which turns out to be 47 3/4. I'm not sure which notation is going to be easiest here, so let's just leave that as that for now. Okay, so part B is f inverse prime of 6. Let's start with that formula. F inverse prime of x is going to be 1 over f prime of f inverse of 6. So I need to find what is f inverse of 6, right? So basically this is the y coordinate. 6 is the y coordinate in the f of x, and I need to find out what do I plug into f of x to give me 6. Right, so we're taking that 6 and we're setting it equal to our f of x function. And we're trying to figure out what number do I need to plug into this 6, or to this function to give me 6. And we just like try some numbers at first. Like if I plug in 1, I get 1 minus 4. If I plug in 2, I get 8 minus 2, right? Notice if I plug in 2, I get 2 cubed minus 4 over 2, which is 8 minus 2, which turns out to be 6. So a solution to this is x equals 2. Let's see if we could solve it algebraically as well, just for the heck of it. First, I could try on the right-hand side finding a common denominator, which would be x to the 4th over x minus 4 over x, right? I multiplied the left term by x over x. So this will be x to the 4th minus 4 over x equals 6. Multiply both sides by x, I will get 6x equals x to the 4th minus 4. and then I could subtract 6x on both sides, and I would get this. And we could try to solve this, be like x squared, except there's no two things that are going to multiply to give me that and that. So it looks like it's not going to work out. So let's just take our guess and check method up here, which was x equals 2. Right, so f inverse of 6 is 2, which means I need to find 1 over f prime of 2. F prime of 2, I'm going to plug in 2 to my f prime. And let's do that over here. Let me just erase this work since it wasn't really necessary or helpful at this point. And let's find f prime of 2. F prime of 2 is 3 times 2 squared minus 4 over 2 squared, which that's going to be 4. That's going to be 12 minus 1, which is 11. So this here is going to turn into 1 over 11, right? F inverse of 6 was 2. So I did f prime of 2, which was 11. So it's 1 over 11 is what I get there. All right, moving on to this one, f inverse prime of negative 3. If I want f inverse prime of negative 3, I will have to find 1 over the derivative of the inverse evaluated at negative 3. So negative 3 now is my output of my function. So I'm setting up this equation again where negative 3 equals x cubed minus 4 over x. I need to figure out what number can I plug into this to get negative 3. How about 1? 1 cubed minus 4 over 1. So it's going to be 1 minus 4. Right, so x equals 1 here. It gives me a solution. Right, what that tells me is f inverse of negative 3. F inverse of negative 3 is 1, right? Because if I plug in 1 to my f of x, I get negative 3. So now I know that I need to find 1 over f prime of 1. So now we're back to f prime of 1. Let's do that over here on the side. F prime of 1 is going to be 3 times 1 squared minus 4 over 1, which is going to be 3 minus 4, which is negative 1. So this is going to be 1 over negative 1, which is 1, or negative 1. And that is our answer there, just negative 1. All right, let's keep going and do this last problem here. So position of a particle is given by this guy here. Find the intervals when the particle is moving left. Remember, if it's moving left, the velocity is going to be negative, and find the intervals when it's moving right. Remember, if it's moving right, the velocity is going to be positive or greater than 0. In order to determine when it's negative or when it's positive, I first need to know when it's 0. So, and before I can even do that, I need to find the velocity function, right? So the velocity function is the derivative of the position function. So we're taking the derivative of this function up there, which is going to be this, t to the third minus 6t squared plus 8t. I need to know when is that equal to 0, so we're going to set it equal to 0. The reason I want to know when it's equal to 0 is because that's when it will switch between positive and negative. Or let's go ahead and start factoring it. I can factor the t from everything. And then I can factor the inside to be t minus 4 and t minus 2, which gives me 3 solutions. T equals 0, 4, and 2. So I'm going to go ahead and put those on a little number line here. 0, 2, and 4. And now I need to know where the velocity is on each side of this, right? So the first thing I'm going to do is I'm going to plug in a number over here on the left-hand side of 0, right? Pick a number over there, like negative 1, right? And imagine we're plugging in negative 1 to this. It's going to be negative 1. And all you got to know is the sign. If the plug in negative 1 here, it's going to be negative. This is going to be negative. This is going to be a negative. A negative times a negative times a negative is a negative. So from negative infinity to 0, it's moving left. All right, from 0 to 2, we're going to plug in a number, maybe like 1, right? Plug in 1 here, positive, this will be negative, that will be negative, which in that case you have 2 negatives, this is going to be positive. Negative times negative is a positive. Right, next one here, plug in 3, positive, negative, positive. You have one negative, it's going to be negative. All right, and after 4, you can see it's going to be positive, that's going to be positive, that's going to be positive, everything's going to be positive. Okay, so that's just to write the intervals. So when it's moving left every time the velocity is negative. So it's going to be negative infinity to 0, and then 2 to 4, right? Everywhere where the velocity is negative, and it's going to be moving right is going to be from 0 to 2, everywhere it's positive, and then 4 to infinity. All right, so that's part A. Oh gosh, so my lettering again is off. Part C is find the time intervals when the acceleration is positive and the intervals when the acceleration is negative. To find the acceleration, I need to take the derivative of the velocity. So the acceleration function is going to be 3t squared minus 12t plus 8. And again, if I want to know when it's positive or negative, I first need to know when it's 0. So we're going to set this function equal to 0. Go ahead and start factoring. 3t and t. I got to figure out how this is going to work so I can get negative 12 in the middle. I know the last two terms have to multiply to give me 8, so it could be like 8 and 1, 2 and 4, or 4 and 2. And I think, and they both have to be negative because I'm getting a negative in the middle. So I think it's going to be 4, 6, that's not going to work. I'm thinking like 4 and 3, sorry, 4 and 2, that would give me 6 and 10, and it looks like it's not going to be factorable, so we need to instead try something else, which in this case is going to be using a graphing calculator, which is a good opportunity to do this. Let's go ahead and go to our graphing calculator and let's plot this function, 3x squared minus 12x plus 8. Go and graph it. We want to know when it's equal to 0, which is basically going to be our x-intercepts here. So I just need to find these x-intercepts. And the way to do that is second trace when you want to find zeros. Follow the instructions on here. It says left bound, which means be left. Right bound, that little cursor will be right. Guess means get somewhere close. And we're going to get t equals 0.845. That's one value. And then let's go and do the other one. Again, second trace 0. Go over here, it needs to be left of that 0. And then you need to go right of the 0. And then you need to guess. And that one's going to be t equals 3.154. And again, we used our calculator here, right? And then let's go ahead and do a little chart here. We have 0.854 and we have 3.154. That's cool. It's pretty close to pi. And I don't even need to like check this. I can just look at the calculator, right? Look at the calculator. Before 0.845, the acceleration is above the y-axis, so it's positive, right? Before here, it's positive. After that first x-intercept, it's negative, and then after the second x-intercept, it's above the x-axis again. So it looks like that. So we're going to say accel is positive from negative infinity to 0.854, not including either one, and from 3.154 to infinity. And then the acceleration is negative from 0.854 to 3.154. All right, so that's that. And then for the last one, over which time interval is the particle speeding up? Remember, speeding up is when the velocity and acceleration have the same time. So we need that same sign. So we need to be looking at both of these intervals at the like basically on top of each other, right? So I'm just going to draw one line here, and we're going to put 0. We're going to put 0.854. The next one in there is 2. The next one in there is 3.154. And then the last one is 4. On the top, I'm just going to do my velocity, which is negative, it's positive from 0 to 2, negative from 2 to 4, and positive afterwards. And for the acceleration, it was positive always until 0.854, and then it was negative from 0.854 until 3.154, which is there and there, and then it becomes positive again from that 3.154 to there. So when is it speeding up is when these signs are the same, which are there, there, and there. Right, so what are those intervals? Well, it's from, let's say it's speeding up from 0 to 0.854, and 2 to 3.154, and from 4 to infinity, right? Because that's where the sign of acceleration and velocity were the same. All right, I hope this is helpful.